Welcome to the pre-lab material for JOS 1701, Finding Your Way with Maps, or Introduction to Mapping module. This is part 3 of the introduction material. In this section we'll consider which way is north. So how do we find our way using north as one of the key points of the compass upon which to base our position and our bearings? In the previous couple of introductory videos, we've actually looked at a couple of key concepts. The first was the use of the graticule. This was the network of lines or meridians of longitude and parallels of latitude that can be placed over the globe to tell us the location of key features on the globe. We use, for example, the main lines of latitude to define climatic zones, such as our tropics, the equator, and the Arctic or Antarctic circles. We also saw that the prime meridian that's been adopted is typically the one which passes just outside London at the Greenwich or the London Observatory at Greenwich. And so we tend to talk of points either being east or west of this prime meridian or north or south of the equator. Note that if we didn't cover it previously, normally by convention in digital data sets, values to the north of the equator are given positive signs in, say, for example, using them on Google Maps or other technology such as that, and values south of the equator are given negative signs. Similarly, we have values to the east of the prime meridian given positive signs, and values to the west are given negative signs. So please note that sometimes we refer to things as north or south, or in other situations they're referred to as plus or minus values. Now, we also saw in that previous couple of introductory videos that we often don't navigate using the graticule because it becomes a bit cumbersome, especially at the local scale, and we often tend to rely more upon grids. Grids are useful because we know that there's a fairly standard distance between grid lines, typically of 1 kilometre spacing. So in the previous video we introduced the concept of the Australian map grid and using area references or grid references based upon that grid to define locations. So we saw that grid lines can give us coordinates, and so on topographic maps grid lines typically appear, and these are also numbered typically in the margins of the actual topographic map. So here across the bottom we can see the eastings, or the distances east from some false origin or starting point defined here. So the numbers 7, 8, 9, 10, 11, etc. are literally distances in kilometres east from some starting point. Up the right hand side of the actual map here we can see northings, or distances north. So we have distances in kilometres from the starting point of a particular zone of the topographic map. So in this case here, 86, 87, 88 are all distances north in kilometres. And we give a coordinate using an easting and northing. Now if we look at the actual borders of the map sheet, you'll also notice that besides showing the actual grid lines, and the map shows the grid lines, but the borders show the numbers that are the labels for those grid lines, in the corner you'll also notice that there are latitude and longitude values shown. The value 151 east here is actually shown as defining the actual right hand margin of the actual map sheet. So the map sheet itself does have a particular line of longitude, in this case 151 east, defining its margin. Similarly, the bottom margin is defined by a line of latitude, in this case 34 degrees and 30 minutes south. So those two examples of that particular parallel of latitude or meridian of longitude define two sides of the map sheet. Of course there will be another two sides defined, the top and the left hand side, for example, in this sheet, that are defined by those particular lines of latitude. Now, what we'll also notice here is when we compare the grid lines on the map versus the lines of longitude, or the borders of the map as shown here, you can see these two things are slightly different. So we can see the grid lines are the network of the pale blue squares here that show up clearly against the ocean. And the grid lines are part of the map grid of Australia. This is a modern map or a newer version of the map, so it's the map grid of the Australia or MGA. Remember previously they would have been AMG or Australian map grid. But the map grid, the lines in this case are for map grid of Australia. Now notice the actual borders of the map sheet, that means, are part of the graticule. So this is actually the network of lines of latitude and longitude. Now if you compare these things, and I've embellished the grid lines and the margins slightly here with these big bright orange lines, you'll notice they're not parallel. You can see there's a divergence between the lines defined by the grid lines and the actual borders of the map. Probably most obvious on the bottom, but you can see it also is fairly clear on the right hand side. Why is this? Well, it's like that because essentially one set of lines is square, which are the grid lines. It's a nice Cartesian, nice regular geometric grid, whereas the other lines, remember, are curved because they're lines on the curved surface of the Earth. And so the grid lines are quite square and regular or orthogonal, whereas the actual graticule, of course, are curved lines. And we know also that the lines of longitude, those meridians of longitude, converge as we get closer towards the poles as well. So here we can compare these two things, the grid versus the graticule. Now I've got the grid on the right hand side here and the graticule on the left. So the graticule is made up of those curved lines and they're sort of shown up in the diagram here, whereas the grid is made up by these straight lines. So that means we also should appreciate we have two different values for north. What we normally think of is true north, and true north actually follows a line of longitude because, as we know, all lines of longitude or meridians of longitude will in actual fact converge at the North Pole at Santa's house. Now we also find that we've got a line for grid north as well, and these are defined by the grid lines. Now if you read the notes that's available on Moodle, it explains this in a little bit more detail, but essentially making maps is all about a compromise. You're trying to get a flat surface onto a curved surface. The flat surface is either the bit of paper the map's printed on or also the screen that you're looking at it on. So there's always going to be some sort of fudge factor or at least some sort of squeeze and manipulation of the data here to work. And basically that's why grid north and true north are rarely the same thing. There's going to be a little bit of a mismatch here because it's just hard to try and put a flat bit of paper over a curved surface. That's simplifying it grossly, but it's enough for us to realize the two types of north. So if we look at it now, we can see there's actually a convergence between the two types of north. Grid north, or GN, is shown on this diagram, and true north, or TN, is shown on this diagram. Remember, true north is based upon the graticule, latitude and longitude, and grid north is based upon eastings and northings, the grid applied to a certain area. As we saw, these things typically will actually not align properly, and there'll be what we call some angle between them, which is what we call grid convergence. So that angle is typically quite small. We don't want it to be too large, otherwise the map is not very useful. So grid convergence is typically only measured, as you can see here, in fractions of a degree. In this example, the grid convergence is given as 0 degrees and 3 minutes of arc. So it's actually quite small. So that makes us start asking questions like, well, which north do we use? And the maps show several. They don't just show grid north and true north. Most topographic maps produced in Australia and in many other parts of the world would actually show three types of north. The grid north that we've been speaking about using grid references and coordinates like that. True north, which we now know follows the meridians of longitude. And there's typically also another north shown here as MN on the diagram, which stands for magnetic north. So now we can see that there are actually three different types of north that we could refer to. So true north and grid north we've explained, but why is magnetic north different to the others? Magnetic north is what we used to navigate with before we all started relying heavily upon our phones or GPS units to tell us where to go. Magnetic north follows the compass needle. The compass needle simply is something which aligns itself with the Earth's magnetic field. So typically we could always work out where north was using the compass, compare that to values on a map and know which way we had to head to go from one place to another. So ships and people, walking through the bush and a whole range of applications relied upon compasses. These days, most people will have a compass as a backup in case there's no GPS signal, but almost everyone is starting to rely upon GPS as the main coordinate system these days. So if we look at the compass, it points towards the magnetic North Pole. So when it points north on the compass, it's pointing towards the magnetic North Pole. Now that's not the same as the geographic North Pole, which is where Santa lives, and where the lines or the meridians of longitude converge. The magnetic North Pole you see here is slightly off by, well, it's over 1,000 kilometers or more from the geographic North Pole. So it's actually quite a long way away. Now, of course, that doesn't make too much of a difference, but it's enough to be important if you're actually navigating using the compass needle. More importantly, we know that that magnetic North Pole wanders over time. Indeed, sometimes it flips between a North Pole and a South Pole, and it does that over very long periods of geological time. But certainly what we do know is over more historical time frames, the actual Earth's magnetic field varies, and therefore so does the location of the magnetic North Pole. Here's an example for the last 400 years or so, showing where the pole has been previously and where it is now. Now also we find that therefore the variation between true north and magnetic north is slightly different for any part of the Earth's surface. Here's a map of Australia which shows what the variation is between magnetic north and true north for different parts of Australia. You see some places the variation is very small and for others it's quite large. So hence this is actually quite important. For the eastern states the variation is measured in the order of more than 10 degrees. So this is quite an important difference. For the western states the variation is much less. So certainly navigating by a compass in the eastern states we should be aware of this 10-degree or so difference. Now back to our diagram here, we see that we normally refer to the difference between magnetic north and grid north as something called the grid magnetic angle. When we compare that to the difference between true north and magnetic north, this is referred to as magnetic declination. And so we should realize that magnetic declination and the grid magnetic angle aren't the same thing. They are slightly different. And so the magnetic declination is a combination of the grid convergence and that grid magnetic angle, and that becomes the magnetic declination. As we said, this can be in the order of several degrees in some parts of the world and is quite important. Now, what we also know that because the magnetic pole wanders or varies in position from one year to the next, and certainly over hundreds of years, there'll be a change in that grid magnetic angle and a change obviously in the declination as well. So what we see is that declination will change over time. And in this case of New South Wales, this angle is getting slightly larger each year. So the difference between grid north or true north and magnetic north is getting slightly greater each year. So if we were using maps based upon a map 30 years ago versus today, we have to make more allowance today of that difference if we're using the compass than we would 30 years ago. Okay, that ends the material for this part of the pre-lab. So we've covered direction and north points as well as actually thinking about grids, graticules and location. Again, please look at any notes and exercises on Moodle and complete them before your lab class. Thanks and good luck.